Alrighty. Okay, so it looks like it might be an easy one today. Find the most frequent vowel and consonant. You're given a string S consisting of lowercase English letters. Find the vowel with maximum frequency. Find the consonant with maximum frequency. Return the sum of the two frequencies. If multiple vowels or consonants have the same frequency, you may choose any of them. If there are no vowels or consonants in the string, consider the frequency 0. Okay, I think I'm going to use a counter to maybe we'll call this frequencies to count how many of each vowel there are, and I guess I'll just use a for loop to go through every letter. Go through every letter, I guess. Yeah, for every letter and frequencies. If the letter, let's say I create a vowel set, A, E, I, O, U. The letter is in the vowel set, and I'll say max vowel frequency is 0, max consonant frequency is 0. If the letter is a vowel, then take the maximum that and the current max vowel frequency. So frequencies of this letter else max consonant frequency is max of the max consonant frequency and frequency of this letter. I wonder if I can iterate through the items, I guess, for each letter and the frequency of that letter. I think maybe that might be slower, to be honest. Because when you iterate through the items, it might actually need to create the items. I'm going to go and just use this first, see if it matters. Return max vowel frequency plus max consonant frequency. Frequency frequencies of the letter. Okay, so first thing I'm going to test is we're not using iterating through items. So for every frequency, letter frequency in frequency.items, and then just use, probably shouldn't be editing the thing, rather than like creating some additional version of it. Okay, so now back. That, yeah, items, I think I maybe recall a previous instance where trying to iterate through the items just made it slower. So that, not that. This is why I should have done. Okay, so what other things could it be that is, I could iterate over do a hard array, and then just I could do a more hard. What am I trying to say? Since there's 26 lowercase letters, I can do a hard hard integer array for the frequencies and not use kind of a counter. Create my own. Okay, let's just try to create my own. So frequencies is a array of zeros times 26 letters, and then for every letter in, let's say, offset equals, actually, yeah, this converting Python convert character to integer. Yeah, that just converts the actual digit. I think I want to do ordinal, yeah. Okay, so I want to just use offset as the ordinal value of A, character A, and then for every letter in S, the frequencies at the index that is the ordinal of this letter minus the offset is incremented. And then I guess I still want vowels. Well, I'm just going to hard code it. Vowel offsets are going to be 0, let's say, alphabet letter indices. Okay. 0, E is 4, I is 8, 14, 20, 4, 8, 14, 20. 4, 8, 14, 20. So max vowel frequency is the maximum of frequencies of 0. Should I use a for loop here? Frequencies of 4, frequencies of 8, frequencies of 14, and frequencies of 20. Oh my god. I don't know. I still have to do the consonants. Okay. For every index in range of 26, if index, this makes it needs to be set. If index in vowel offsets max vowel equals max consonant equals 0. Max vowel equals max of max vowel, and the frequency at this index. Frequencies at this index. Else max consonant equals max consonant count, and frequencies at this index. Turn max vowel plus max consonant. Still feels slow. Yeah. As slow as the first. Hmm. I think my brains to make this faster. S. Go through all the offsets. I don't really know if this is any faster. Creating my own array. I feel like there should be something slight, like the if statement really slows it down here. So I think maybe if I tried something like this, frequencies of 0 equals frequencies of 4 equals frequencies. God, that's the typing speed is questionably inaccurate, or my typing is questionably inaccurate. Okay. And then max consonant is just the maximum of the stuff that's remaining. And then return max vowel frequency plus max consonant. Good old 3 milliseconds. Guess I don't need this in this last iteration of counting. Frequencies. Create my frequencies array. Find the maximum of those particular frequencies. Zero them out. Find the maximum of consonants. Let's see if it was just, no, it's just not random. Alright, this one I'm actually just curious. What is the default dictionary? They actually use items. For every key value, okay. With the keys and vowels, if the value is greater than value max, they use, instead of max equals, they use if statement. Else if the value, let's see. So they limited the number of times it actually made, so they, let's see. So what they did was, instead of using max like this, which will automatically always assign, they only assigned if the thing is actually bigger. So if it's like max vowel is greater than, I guess maybe that's the one that's more familiar, would be something like this. I think if they didn't use the items, it might be faster. So if the letters and frequencies and the frequencies of this letter is greater than the max vowel frequency. Actually, this needs to be separated. Then update the max vowel frequency. So it removes a. I guess maybe I can do it and here. No, I can't. So if it's not, then else. I think I can do an else if here. Frequencies of this letter is greater than max constant frequency. Then only then would you update the max constant frequency. Okay, I think this is what they did to make it faster. Max vowel frequency. Keep missing out the S. Max vowel in tab this. You can't do an if and here, if this and this, because the else would then also need to check whether or not the letter is not in vowels. Because otherwise it could just be failing in the second clause. Second condition. Huh. I wonder. Doesn't actually speed it up all the way. I guess they did use, instead of a set, they use an array. I wonder if that's actually faster for some reason to see if a letter is an array rather than nope. I guess the other thing that they did was they actually used a default dictionary. Alright, well, I don't think I want to copy everything, so I'm good with whatever that came out to be. Okay, well, summary. This is going to be pretty relatively straightforward problem to use some data structure to tabulate frequencies of letters in a string. So the common ones might be a counter object, creating a counter based on a string. 2 would be a default dictionary of integers where you use the vowel as the letter as the key and increment the value each time you see the letter. And lastly, it might be array of ints for counts, index, use convert letter to ordinal value, where basically a equals 0. Etc. And use ordinal value to as index, incrementing the value at that index, and then have some way to iterate over vowels of your counting of your frequency object, updating a max vowel frequency variable if the frequency is higher. Do similarly for consonant. Obviously, you can do something where if it's a vowel, then update the max vowel frequency. It's a consonant. Else, it would be a consonant, and then update the consonant frequency if it's higher. So, let's see this go O(n), iterate over the n letters of the string to determine the frequencies on the first pass, and to determine the maximum vowel / consonant frequencies on this later passes. Okay. Space complexity. This is just going to be O of 1 as the object for tracking frequencies. Will generally be 26 integers or so in size, not proportional to the length of the string. Alright, cool beans.